Mario vs. Bowser, a Cell Edition, by Ariana Jerez and Sofia Ono-Korkowski.
All of our cells have different proteins that have different functions or roles. For example, our cells have cell membranes. Shown by the yellow arrows here, there are different proteins in the cell membrane that let it do its job. In order for proteins to work the way they should, they have to be folded correctly. The ubiquitin proteasome pathway is one way that our cells get rid of proteins that don't work properly. This pathway isn't much different from a game of Super Mario. In order to break down the proteins that no longer function, we need two things: a chain composed of ubiquitin tags and some enzymes. Enzymes are proteins that speed up chemical reactions, and ubiquitin tags are proteins that serve as a label that allow the enzymes to recognize them and break them down.
Enzymes 1, 2, and 3 will be stored by Princess Peach, Luigi, and Mario. The protein to be degraded, the ubiquitin tags, and the ubiquitin chain will be stored by Bowser, Fireball, and a series of fireballs.
As you can see, Peach is activated by this ray of energy. In our bodies, this energy is in the form of a molecule called ATP. This allows her to collect the fireballs and pass them to Luigi.
Luigi then passes the fireballs to Mario.
Finally, Mario, who already has Bowser captured, attaches the fireballs to Bowser. This process repeats itself until the protein to be degraded, aka Bowser, has a chain of ubiquitin tags. Now that Bowser is marked or tagged for his demise, he will be moved to the castle where he will be degraded. The castle in this case represents the proteasome complex, which consists of other enzymes that break down proteins, called proteases. These will break down Bowser. As you can see, Bowser was taken to the castle, aka the proteasome complex, and is degraded by these enzymes called proteases. The main takeaway from this game of Mario is that the proteins that don't get folded properly must be broken down. If these misfolded proteins aren't disposed of properly, bad things can happen to our cells. For example, neurodegenerative diseases such as Alzheimer's and Parkinson's have been linked to the accumulation of misfolded proteins.
Alzheimer's is a disease caused by an aggregation of misfolded proteins, and the ubiquitin proteasome pathway helps to make sure that these misfolded proteins don't accumulate. However, if this pathway isn't functioning properly, not only does it fail to degrade the proteins, but it also accelerates their aggregation. Ubiquitin can become mutated or changed into another form, which causes this accelerated accumulation.